So I made this animation with Procreate. What I did was turn on the onion skin frames, which allows you to see the previous layer, and it's useful for animation because it lets you make the animation a bit more cohesive. But Procreate also has this feature that allows you to see a time lapse of what you were seeing while you were creating whatever document you are producing with Procreate. So I took advantage of that by going through each frame as I was making the animation and adding this dot in the corner so that when you look back through the time lapse, you can see it kind of overlaid and have this smooth animation. But it wasn't as fast as I wanted it to, and because I was using the onion skin feature, I couldn't really control the frame rate. So I wrote a script in Python to do this for me. This takes an input of a Photoshop document, which you can export from Procreate. And while Photoshop does have a feature that allows you to export each layer individually, because this is 650 megabytes, I couldn't actually do that quickly. So if I wanted to change just one layer, I would have to go through the process of loading this into memory, this entire file, and that just wasn't really efficient. Because there are a few things about this animation that I found out that I actually wanted to change. The entire script that I have is in this run.sh file that makes some directories for output, builds the input. So here you can see that I have an input.psd file and a psd extracted file, which has each layer extracted. When I first created this script, I don't think that I was... When I first created this script, I was using an animation that had background colors, and that was making each file a bit larger than I wanted it to. So I actually had to go back through this animation and remove all of the backgrounds so they would be transparent. And this entire folder is actually pretty large, 234.5 megabytes, which is a bit smaller than 650.3 megabytes. So that did actually make that part of the processing a bit easier. One of the main things that I wanted to do with this animation was have each layer kind of overlaid with the others. So I wrote another script called generate layers, which actually goes through each of the files and combines them depending on what you set in your run.sh file. So this has a composite depth of 3 for composited 3, which means that for each outputted layer, these are all WebPs, so I can't, actually I think I can WebStorm. So for each of the frames, there's an amount of transparency that you can see it's overlaid with. And I did this because I wanted to make the entire animation feel a bit smoother than what the frames in the Photoshop document would indicate. Let's see if I can make these a bit bigger. Is there a thumbnail size? I forgot. Panel options. There we go. So you can see these frames aren't necessarily the most cohesive between each other, but actually having them composited provides a bit more visual cohesion from frame to frame. When I was looking at the output, this was the first one that I made, there were a few different options that I noticed. One of the options while making the actual movie, I have a shell script that does that, generate movies. And there's a lot of noise here, but the main thing to look at is this ffmpeg call, which is a script that essentially goes through all of the frames in this folder and compiles them into videos. So the two options that I had were MP4 and WebM. MP4 was a lot larger. You can see this file is 61.34 megabytes compared to the WebM's. The largest in this folder is 27. But you can see that there's a lot of variety in the actual size. So 2.22 to 27.38. It's 10 times different. Now I was kind of curious about reducing these. So this constant rate factor of 5 means that the quality is going to be higher. Lower CRFs indicate higher quality. And higher CRFs generally indicate lower quality, but I noticed that this constant didn't actually affect the MP4 quality at all. So the 6.34 megabyte video, while it's a lot smaller than its equivalent for the CRF5, the quality turned out to be pretty similar for the same type of video. So I actually kept that noted in this .keep folder. Eventually I'm probably going to get rid of these two folders because, as you can see, combined, they're about 1.15 gigabytes. That's significant. I have this log.tsv file that keeps track of each step. So video per video, this keeps track of how large the video is, how long it took, and the total time. And they're all organized into folders based on the batch ID, which is just a UUID. Something to note, in the first run I ran 60 iterations, but I actually pruned that down to 30 to be a bit more tolerable. The main thing that I did was what did I get rid of? I got rid of the 5 frame per second video because I wasn't really going to use that. That was mostly to see each frame as it was going by, but that's not tremendously necessary. And I also got rid of the 13 CRF iterations because I just didn't really care about these as much. That got the folder size down pretty significantly, from 796 megabytes to 343 megabytes. And I can probably go one step further and get rid of the 26 frame per second version, because one of the abilities for the playback in the browser, which is where this is going to be, is to display this at quarter speed. So if I have a 26 frame per second or 13 frames per second video, which is 14 megabytes larger in this case, let's see a better example because the CRF setting doesn't actually matter for the MP4s. So theoretically, if I wanted 13 frames per second, I could just play the 52 frames per second video at a quarter speed and save 4 megabytes. The CRF version, the savings are more significant at 14 megabytes. Although I'm not going to use this, just an example. Is there anything else to say about that? I think those are the main things. Alright, the time run. So in generating these, just by getting rid of the options that I know that I'm not going to use, I took it down from 1,254 seconds, which is about 20 minutes, to 686 minutes, which is about 10. The next steps are to go back through this animation and notice that there was a lot of artifacting, regardless of the CRF setting, for the WebMs at the beginning of the animation, It's more noticeable for the 26th CRF version. It's less noticeable when the buffer size is large. So for 15 megabytes of a buffer, the WebM turns out to be pretty similar quality to any of the MP4s. If you look at the 500 kilobyte version, you can see at the beginning there's a lot of artifacting, a little bit less at the end, but throughout the entire animation there's a lot of artifacting. It's 13 frames per second, buffer of 15 megabytes. 1 megabyte. At the beginning there's a lot of artifacting. Towards the end that actually looks relatively okay, and I believe that has more to do with the number of colors and the complexity of the image. Makes it hard to compress well. So the next step for me, also looking at, I guess, 52 frames per second version, 15 megabytes, that's 11.2 megabytes for output, which is twice the size of the same for the MP4 version. But my question here is, can I maintain the quality just by getting rid of some of the complexity at the earlier stages of the animation with those frames? And I think I can. So I'm going to try that and then rerun this entire script. There are also a few things that I can do in terms of making this animation smoother by changing the layers of composition. Having higher layers of composition makes the files a bit larger. Because the images are a bit more complex. That's something that I would look into at some point. Is that everything? I think so.